Hi, Nikki. So you said you were having trouble getting your critical value. So I'm going to show you here a couple of things that might help you with this issue. So first of all, there are two ways to get your critical value. One is with the standard normal table, and I'll show you how that kind of works. And then the other way is with StatCrunch, and I feel like that's the easiest way to get your critical value. So first of all, just to get a picture to show you what a critical value is, I'm just going to go to question help here. And I'm going to go to, I think under view and example, they might have a picture for me. Let me just check here. They may or may not. And they don't. So let me go to my text here. So let's just see. Sometimes it helps just to have a picture as we're talking about this. So let me just grab my text. And we'll bring up the Pearson e-text here. Sometimes some of these questions actually have a link to the text, and this one just didn't, unfortunately. So this happens to be question 9.1.7, so I'm just going to navigate to chapter 9.1. So that kind of gives you which chapter and section it's from, which is nice to at least have a value there. And so we're estimating a population proportion, and they're talking about what that point estimate is. And then, oh, here's my nice picture. Okay, so if we have the standard normal curve, and I would like to be, this gives us an example of 95% confidence. That means that 0.95 or 95% is the area in the middle of this curve, this blue shaded region. Now, remember that your normal curve is symmetric, and it also has an area under the entire curve of 1 or 100%. So if 95% is in the middle, that means that there's 5% left over for the two sides, but the two sides are symmetric, therefore we just cut that in half, and we have 2.5% over here and 2.5% over here. Now, if we go to the standard normal table, which I'll bring you to in a second, it finds areas to the left of your critical values or of your z-scores. So we would use this little tiny tail here that's 2.5% and find the critical value at this line right here, and then we just use the positive version of that, and that would be your z critical value. Okay, so just to show you that table, so if you go down in your text to your appendix, and these are where all your tables live. I also did put a PDF of your standard normal table in one of your announcements for week 2. So you can feel free to go back, download that to your desktop, and therefore you'll kind of always have it. And I believe it's A11 or 12. So I'm just going to look through here. I apologize for the clicking. This is going to take a little while, so I'll just go. I think it's A11. Oh, and I'm right. Yay. Okay, so what I'm going to do here, if I were looking up a z-score and I wanted to find a probability, I'd be looking on the left for the tenths place, and then I'd go to the right for the hundredths place. But we want to do this backwards. We actually want the z-score. So I'm looking for the area in the middle of the table, and I'm going to find out which z-score that corresponds to on the side and the top of the table. So again, this was, if I look here, we said it was 2.5%, so that's 0.025 as a decimal. So I'm going to get as close as I can, might not be exact. In this case, it actually will be, but it won't always be exact to get my z-score. So I'm going to keep looking through the table and scanning, and sometimes it can be difficult. And this is why it's nice to have StatCrunch. Then I'm going to look for 0.025. And if you see here, I start with the 0.02s right around -2. And then I get 0.0256, 0.0250 exact. So what that means is that this little tiny area over here, 0.0250 or 2.5% corresponds to a z-score. Follow it across, -1.9. Follow it up, 0.06. So -1.96. And I would always use the positive version of that, positive 1.96. Now, again, that was kind of annoying having to go ahead and look through this whole entire table. So the way that you find this through StatCrunch, so go back to your question help, click StatCrunch, and you have this standard normal calculator here. So if I go to Stat, Calculators, and I go down to Normal, you'll see a picture that's very much like the one I just showed you in the text. Okay, now you'll see here that we have a mean of 0 and a standard deviation of 1. That means this is the standard normal curve. And again, we want now the value not to be 0.5. So this is exactly half right now. It's kind of just popped up with half shaded. We want 2.5% or 0.025. So what I'll do here is I'll go down and I'll change this number to 0.025 and click compute. And as you can see here, it's gotten me, it's a little more accurate than the table. It's actually calculating it for me of negative 1.959, but we are always going to round our z-scores most of the time to the hundredths place, the 2 decimal places. So negative 1.96. Now again, you aren't going to put down the negative, you would put down the positive. So looking back at your problem, you needed the z-score that corresponds to 91% level of confidence. So that means I'm just going to click my thing here. Okay, you can also do this a different way. I'm going to show you in a second. You can click between. So you want the area between these two scores to be 91%. So just to show you how I would do this with 95 from before, if I use the between instead, I could say I want the area between to be 0.95 and see how it gives me the negative 1.96 and 1.96, right? Without having to do the whole divide by 2. So for this problem, because you want the area between to be 91%, you would just change this to 91. And now you have the 1.6954. So you would round that to 2 decimal places, which would be 1.70. Okay. Now if I wanted to do it the other way, which was with the area in that left tail, think 91% is in the middle. That leaves 9%, helpful if I can add, 9% for the 2 ends here. And then you divide that by 2, and that's 4.5%. 4.5% is 0.045. So if I were doing this with the table, I'd be looking for 0.045 somewhere in here. So I see the 0.04s. I just need to then go ahead and scan for 0.045, which can be, a little, again, annoying or difficult. But I found it here, right? Negative 1.6, and then I got the 9, right? Or, where am I going? There we are. Or again, I can use it here. If I do the standard, I'd be doing 0.045 here and get my value. Or I can do between and actually plug in the 0.91. So I hope that helps. Honestly, I would use StatCrunch to find this value. It's much easier than scanning through the table.